Right, so let's continue with transformer and know how it transforms the voltage as the power is transmitted from the power station to us at home. Okay, this is a very simplified diagram about how we get our electrical supply from the power station. So in between, there's actually two transformers. I'm not sure whether normally there's more, but typically this is the idea. So for transformer A, let's look at, we have primary coil. Okay, and we have the secondary coil here. Similarly for transformer B. Now, because the voltage supplied at the power station is here, so we have VP, voltage of the primary coil. Okay, now, and therefore a current at the primary coil, right? So and the power supplied by the power station is 200 megawatt. So which means 200 megawatt is equals to the current at the primary coil multiplied by the voltage supplied at the primary coil. So if we know the voltage supply is 2000 volt, so the primary coil current is like 100,000 ampere. Okay, that's a very high amount of current. So it's tremendously, really large amount of current. So if we have this current flowing, for example, without transformer A and transformer B, and we have this current flowing across the entire transmission cables, you can imagine how much heat loss we're going to have. So because the heating effect of currents will be very significant. So what's going to happen is that we're going to step up the voltage. Step up. Yeah, remember, if we step up the voltage, we're going to get a smaller current. Okay, so if we want a smaller current flowing in the transmission cables, we're going to have to step up the voltage. So we want to have a higher voltage at the secondary coil. So let's say the voltage is going to be stepped up to 400,000 volt. Okay, let's look at how much current will be flowing in the transmission cable. So remember, conservation of power. So the power in the secondary coil would be the same. So which means the power at the secondary coil is also 200 megawatt. So we have current at the secondary coil, voltage at the secondary coil. So let's say if the voltage at the secondary coil is 400,000 volts, that means the current at the secondary coil would be 500 ampere. That is significantly much lower, like many times lower than the current in the primary coil. So therefore, the heating effect when the current is flowing through the transmission cable will be way lower. Just imagine if the total resistance of the transmission cable is 20 ohms, just a small number. Okay, so imagine if the amount of current flowing in the transmission cable is 100,000 ampere. Okay, how much will be the power loss? So let's calculate the power loss in the transmission cables, which is I squared R. So I will be the current flowing in the transmission cables and R will be the resistance of it. So let's compare. So if we do not step up the voltage and we simply transmit using 100,000 ampere, how much is the power loss? Well, we can calculate 100,000 squared times 20. So you press the calculator. And okay, it's a really large number. 2 times 10 to the power 11 watts. So that's tremendously large, right? However, let's say if you transmit after stepping up the voltage with a lower secondary coil current, let's calculate and compare the power loss here. So that will be 5 times 10 to the power 6 watts. So as you can see, it's really significantly lower and less power loss. So, because imagine transmission cables are really long, we're talking about large distance, not just like 1 meter or 2 meters of cables. So that would probably be really significant if we could reduce the current that is transmitted in the cables. So when it reaches transformer B, then it would step down to the correct voltage so that we end users can have a safe voltage at our home and suitable voltage too. So that's why we actually make use of transformer to transform the voltage so that when we transmit the power, we don't transmit it at high currents and significantly will have a lower power loss due to the heating effect in the transmission cables. But I hope that's useful for you. Thank you.